Aqueous solutions of salts can either be acidic, basic, or neutral. So when we say salt, we really mean ionic compound, and we know that is composed of a cation and an anion. Cations are positive, so they give positive charge away. They are acidic. Anions are negatively charged, so they're able to attract positive protons, so we classify them as bases. A few exceptions: ions produced from from strong acids or strong bases are neutral. So that's why knowing your strong acids and your strong bases are very important. For each one of these examples, we are going to determine if the salt, when we dissolve it in water, is it going to produce an acidic solution, basic solution, or a neutral solution. The first thing that you need to do is break it up into the cation part and the anion part. So we have sodium cyanide. Okay. Sodium is your cation, the cyanide is your anion. If you see anything that is part of something strong, you're going to cross it out. It's going to be neutral. So I know sodium hydroxide is a strong base, so this ion of sodium is neutral. I can essentially ignore it. It's not going to affect the pH of the solution. Cyanide has a negative charge on it, and negative ions are going to be basic in solution. So this is a basic anion. So together, a neutral plus a basic ion equals a basic salt. You might be asking yourself, well, how is it a base? How does it behave as a base? If sodium cyanide is dissolved in water, it breaks up into sodium plus and cyanide minus. The sodium plus is neutral, but the cyanide minus, when it's with the water, it's going to take one hydrogen away from the water, turning it into HCN, and the water is left as hydroxide. And the creation of this hydroxide ion is what makes it basic solution. Number 2, you have potassium nitrite. So again, break it up into the positive and the negative. Potassium comes from potassium hydroxide. That's strong. That's going to be a neutral compound, so ignore it. The nitrite has a negative charge on it, and negative ions are going to be basic. So the nitrite negative ion in water behaves as a base. It takes a hydrogen from the water, and you produce HNO2 plus hydroxide. And again, producing that hydroxide is what makes this a basic solution. Number 3, you have potassium with the nitrate ion. Well, potassium, as before, it comes from potassium hydroxide, so neutral. Nitrate is part of nitric acid, HNO3, which is a strong acid, so this is neutral as well. So I put two neutrals together, I'm going to have a neutral salt. Number 4, I got something crazy here. I have nitrogen with 3 hydrogens and this methyl group CH3, and then bonded to a chloride. Well, I know chloride, -1, that's a negative ion. So all of this stuff must be the positive ion. I know chloride, HCl, is a strong acid. So the chloride ion is neutral, you can ignore it. The remaining ion is positive, and all positive ions are going to be acidic. Okay, so together, an acid plus a neutral equals an acidic solution. And so if I wanted to write the reaction with water, this behaves as an acid by giving away one of its hydrogens, and it gives it to the water, producing CH3NH2, and the water turns into hydronium. The presence of this hydronium makes this solution acidic. Number 5 here, we're going to break this up into positive and negative. NH4 positive is not part of anything strong, so it's positive acidic. Perchlorate, perchloric acid is strong, so ClO4 is neutral. Together, acidic plus neutral equals acidic. And I can write an equation for the ammonium ion as well with water. It's going to give away one of its hydrogens to the water, producing ammonia, NH3, and H3O positive. And again, right here, hydronium is produced, therefore it is acidic. Number 6, you have strontium nitrate. Strontium is your plus, nitrate is your negative. Well, strontium hydroxide is a strong base, so strontium ion is neutral. Nitric acid is a strong acid, so nitrate ion is neutral. Together, this makes a neutral salt. Number 7, you have bromide here at the end. Okay? And then so all of this at the beginning must be your positive ion. It's not part of anything strong, so that positive ion is going to be acidic. Bromide is part of strong acid, hydrobromic acid, HBr. So this part is neutral, you ignore it. So an acid plus a neutral compound, neutral ion equals an acidic salt solution. And I can write the equation for this in water. It behaves as an acid, so it gives a hydrogen to the water, producing CH3,2NH plus hydronium. Again, the production of hydronium makes this acidic. Number 8 here, you have sodium ion. Well, I know that's part of something strong. Sodium hydroxide is strong, so the sodium ion is neutral. And then you have this negative ion. This is your hypochlorite polyatomic ion. It has a negative charge on it, and it's not part of something strong, and it is a negative ion, so this makes it a base. So together, a neutral plus a base, we have a basic salt. OCl negative plus H2O is going to yield HOCl and hydroxide. The production of hydroxide in solution makes this a basic solution.